Okay, now we see about ideal gas. Okay, so what is mean by an ideal gas? So it can be defined as the gas which follows all gas laws. So what are the gas laws? Charles law, Boyle's law, Avogadro's law, and Gay-Lussac's law. If a gas follows all gas laws at all temperatures and pressures, so that is called an ideal gas. If a gas follows all gas laws at all temperature and pressure conditions, that is called ideal gas. So really, is there any ideal gas is present? There is no ideal gas. There is no ideal gas in nature. Means what is the ideal gas? Means it is only an imaginary gas. Just hypothetical, just only hypothetical gas. There is no perfect ideal gas is present in nature. So nature lo unde gases generally all gases present in the nature are known as real gases. So no real gas can act as ideal gas, but only at particular time, only at particular conditions only the real gases are behaving near to the ideal gas. Okay, so then what are the conditions? What are the conditions where the real gases behaves like ideal gases are? That is very low pressure, at low pressure and high temperature conditions. So it was noted that at low pressure and high temperature conditions, real gases works as ideal gas. Means real gases behavior ideal gas to దగ్గర వస్తుంది, not 100%. They near to the ideal gas behavior at the low pressure conditions and high temperature conditions. So what are these conditions implies that in the low pressure condition, high temperature conditions, so see రెండు conditions దగ్గర ఉండే కామన్ పాయింట్ ఏంటంటే no or negligible intermolecular attractions. అంటే అకార్డింగ్ టు ఐడియల్ గ్యాస్ డెఫినేషన్ ఏంటంటే మనకి సో అంటే లో ప్రెషర్ హై టెంపరేచర్ దగ్గర దే ఆర్ బిహేవింగ్ లైక్ ఐడియల్ గ్యాస్. సో ఈ కండిషన్స్ బేస్ చేసుకుని మనం ఏం చెప్తున్నాం అంటే అట్ దీస్ కండిషన్స్ దగ్గర ఏమవుతాయి, దెర్ ఈస్ నో ఆర్ నెగ్లిజిబుల్ ఇంటర్మాలిక్యులర్ అట్రాక్షన్స్. మాలిక్యూల్ మధ్యలో ఏ అట్రాక్షన్ పవర్స్ ఉండవు, అంటే మాలిక్యూల్స్ అట్రాక్షన్ పవర్ జీరో అవుతాయి. దట్ ఈస్ కాల్డ్ హియర్ ఐడియల్ గ్యాస్. ఓకే, so generally hydrogen and helium or behaves like near to ideal gas when compared to the other gases. Okay, other gases to compare with the hydrogen helium are having near to ideal gas behavior. మిగతా వెరీ రేర్ కండిషన్స్ లో ఐడియల్ గ్యాస్ బిహేవ్ చేస్తే హైడ్రోజన్ హీలియం మనకి మాక్సిమం కండిషన్స్ లో నియర్ టు ఐడియల్ గ్యాస్ లాగా బిహేవ్ చేస్తాయి. Now see the ideal gas equation. Okay, we do the simple derivation. Here derivation is a not important one. So we know that V proportional to 1 by P at constant temperature is called Boyle's law. Okay. So next V proportional to T at constant pressure. That's called Charles law. Okay. Next, V proportional to N, that is at constant temperature and pressure. It is known as Avogadro's law. Just right. So by taking all these equations, we can conclude that V proportional to 1 by P and V equal to, we can write a constant we are taking as R P N by P. So it becomes PV is equal to R T N. Just for convenience, we are writing PV is equal to N R T. This is called ideal gas equation. Here important P, pressure. V means value. N means number of moles. Here important one R. So here R is the constant in ideal gas. That's why it is known as ideal gas constant. T is absolute temperature. Okay. So this is known as ideal gas equation. Now we see some more relations to it. So we know the ideal gas equation, PV is equal to nRT. Okay. And in the place of N, we can write mass by molar mass and make it P is equal to mass by M into V RT. So we know that mass by value. In the place of mass by value, we can write a density. Okay, we can write P is equal to dRT by EM. Okay, this is one type of relation. Okay. So next. Here important one R. So R already we discussed that it is known as ideal gas constant. It is also known as universal constant. So it is very important word, universal constant. మనం ఉన్న ఏ కాన్స్టెంట్ కూడా యూనివర్సల్ కాన్స్టెంట్ అని మెన్షన్ చేయం. ఓన్లీ ఆర్కి మనం యూనివర్సల్ గ్యాస్ కాన్స్టెంట్ అంటాం. బికాస్ at the total universe, for example మన గ్రావిటీ, సో డిఫరెంట్ వాల్యూస్ సన్ దగ్గర, మూన్ దగ్గర, ఎర్త్ దగ్గర డిఫరెంట్ వాల్యూస్తో తీసుకుంటాం, కొన్ని పాయింట్స్ వేరియేషన్స్తో. బట్ ద క్యాలిక్యులేషన్ ఆఫ్ ఆర్ ఈజ్ ఎగ్జాక్ట్లీ 100% ఈక్వల్ at all points of the universe. అంటే ఒక ప్రాబ్లం మనం డిఫరెంట్ క్యాలిక్యులేషన్స్లో ఆర్ వాల్యూ తీసుకోవాల్సి వస్తే అది ఏ ప్లేస్లో అయినా వీఆర్ టేకింగ్ ద సిమిలర్ వాల్యూ. Means R is taken as a constant as whole universe. That's why it is called universal constant or ideal gas constant. So now we write some values for this constant in different units. Okay, here we can take some for 1 mole. This equation written as PV is equal to RT. So PV by T is equal to R. R is, we know that, is a constant. With the help of PV by T is a constant, we can derive an equation that is P1 by T1 is equal to P2 V2 by T2. Means at a particular condition P1 V1 by T1 is equal constant, and by changing other conditions P2 V2 by T2. So both are constants, but we can equalize them. So we get P1 V1 by T1 equal to P2 V2 by T2. In the same way, here also we will get another relation for a same gas. If you take the same gas calculate same values equal untai kabatti, that is P1 M1 M is equal for a gas. So one gas మనం calculate చేసినప్పుడు molar mass same ఉంటుంది. So ఇక్కడ R value same ఉంటుంది. అంటే for a gas, for example we can write P by dt is equal to R by M. R constant, molar mass constant. So we can write it as constant. So constant కాబట్టి P by dt is equal constant. దీని బేస్ చేసుకొని ఒక పర్టికులర్ కండిషన్ దగ్గర P1 by d1 T1 is equal constant. ఇంకో వేరే కండిషన్ దగ్గర P2 by d2 T2 is equal constant. రెండు కాన్స్టెంట్స్ కాబట్టి we can write it as P1 by T1 d1 is equal to P2 by T2 d2. So these are the equations useful in the calculations. Okay. Now we see the values of ideal gas constant. So now we see different units, different values in different units. So what is PV is equal nRT. So R find out cheyali but R is equal to right PV by NT. Okay, generally మనం calculation purpose 1 mole calculate చేద్దాం. Okay, if n equal to 1 mole. Okay, T temperature తీసుకున్నప్పుడు always we take 273.15 Kelvin. Okay, so that is always we are taking 273.15 Kelvin per temperature. That is generally known as basic value for absolute scale. So a fixed number of moles, temperature fixed. Ikkada change values at the pressure units and volume units. So for example, if you take the pressure, okay, pressure manam means R equal we can write so expand cheste pressure into by moles into temperature. ఇక్కడ 1 mole ఇక్కడ చేంజ్ తీసుకోమని జనరల్గా టెంపరేచర్ 273.15 దాంట్లో there is no possibility of units, no అక్కడ చేంజ్ చేయడానికి ఏం లేదు. సో ప్రెజర్ వాల్యూ చేంజ్ చేయొచ్చు. సో ఫర్ ఎగ్జాంపుల్ ఈవెన్ ఇఫ్ యూ ఎక్స్పాండ్ దిస్ ప్రెజర్ ప్లస్ రాయొచ్చు. ద ప్రెజర్ ఇస్ జనరల్లీ ఫోర్స్ పర్ యూనిట్ ఏరియా. ఓకే, ఫోర్స్ పర్ ఏరియా, force per unit area we can write it as like this. Temperature, okay. So volume lo manam am differentiate. So again area, so in the place of area we can write length square. Okay, so volume also we can take length cube. Volume means always length cube is known as volume. Area means length square, length into length, that is length square. Moles into temperature. So by crossing this length square, finally we will get force into length by moles into temperature. So మనం then further the values find out చేసేటప్పుడు so ఈ force units length unit base చేసుకుని we get the different units of R. The pressure బదులు different unit, okay, length బదులు different unit. So moles అంటే always 1 ఉంటుంది, temperature always 273.15 Kelvin. టోటల్గా మనం R వాల్యూ per mole per Kelvin కి ఫైండ్ అవుట్ చేస్తాం. So by substituting a different values in different units, we get different values of R. Now we see what are the different R values. Okay. Okay, now see the numerical values of capital R. So we know that capital R, so capital R equals, we know that PV is PV by NT. So for example, if you follow the SI method, SI units, what is the unit for pressure? So in SI method, the pressure units are Newton per meter square. Okay, then what is the value? Value is 22.4 10 power minus 3 meter cubes. Okay, so my ఇక్కడ SI method లో value మనం జనరల్గా మీటర్ క్యూబ్ లో తీసుకుంటాం, not in liters. Okay, so by substituting these values are equal, we will get so what is the at STP, and again we are calculating at STP. Okay, at STP 1 mole of gas, we are taking always here 1 mole of gas. 1 mole of gas, how much pressure means? It's a constant, that is 101,325 Newton per meter square. Here value is 22.4 into 10 power minus 3. And what is the number of moles? That is 1 mole. So what is the temperature? Kelvin, 273.15 Kelvin. Okay, so on this total approximate calculation, you will get 8.31, and this Newton per meter square into meter cube by Kelvin. So in the place of, you can write joules. Okay, joules. In this total value, Newton per meter square into meter cube, here we will get 8.314 joules per 1 mole and per Kelvin. So this is the main unit of capital R. 8.314 actually, 8.314 joule into mole per Kelvin. Let's see, if you take P is equal 1 atmosphere, then value becomes 22.4 liters, and we know that N is equal 1 and temperature equal, we take 273.15 Kelvin. Okay, so on substituting here, R is equal P into V by T, means 1 atmosphere into 22.4 by, so 1 into 273.15. Here R value we will get on this calculation 0.0821 atmosphere liter per mole per Kelvin. So this is also one of the most important unit. Next, we convert this joules unit into ergs. We know that 1 joule is equal 10 to the power of 7 ergs. So in the place of joule, we can write 10 power 7 ergs. Therefore, R value becomes R is equal 8.314 into 10 to the power of 7 ergs per mole per Kelvin. Okay, and there is some more units are there. So how you got this unit? Units settle వచ్చిన just idea ఉండాలి. No need to by the total process. Just ఈ different units settle వచ్చిన మనకు idea ఉండాలి. So our different values మాత్రం perfect గా we need to remember for the different calculations. Okay, now we see some more values for R. Okay, these are the main 5 values of capital R, mainly used in the calculation of pressure, volume, or number of moles in PV is called NRT. So generally in all calculation we use only these 5 capital R values based on the other units given in the problem. Okay.